Let us start today. LMS portal is not working. So I have tried. LMS portal is not working. So I will give you assignments according to the screenshot of your class here. Okay. Let us do it. Now we have discussing the strain rosets. You know what we have done. We want to know the strains of different points and we want to measure it, not by calculation but by means of a electrical equipment called strain gauges and total, and that too in different point over the surface of a particular body, and this set of stresses is defined as the strain rosette itself. Now let us discuss two mathematical problem. One I have already discussed, but possibly the repeat will help you a bit better. Now the problem was like this. Just 1 second. The problem was like this. The strain measured by a three-element rectangular process. We have discussed that can be three, that can be four-element rectangular rosettes, and those can be also set in a different manner. Here for this problem, we have set the rectangular rosette. The rosette in rectangular form means these two sides of it. We can imagine the states. One rosette is set in this line as epsa A, and one is an epsa C, and which is more or less at the two adjacent sides of a rectangle itself. That's why it is called rectangular rosette itself. Now, our job is to find the principal strain by using the transformation, then also perhaps do the same on graphically and compare the result if there is any difference. So what we are doing here is we have epsa A is given as 700 into 10 to the power minus 6 micrometer per microcentimeter per centimeter of elongation. epsa B 300 into 10 to the power minus 6 per centimeter or microcentimeter per centimeter displacement, and 300 into 10 to the power minus 6, both epsa B and epsa C are same. So here epsa is 700 into 10 to the power minus 6, epsa B is 300, and epsa C is 300 into 10 to the power minus 6 is 7. What we are doing now, first what we have to do is we have to use the equations like this. Using the first we have to do the analytical relation. We are assuming that epsa X is along epsa A. Epsa X is along epsa A, and epsa X is along epsa A, which is equal to 700 to the power minus 6. Epsa Y is equal to epsa C, which is the vertical like here. What is like this? Epsa A is equal to epsa 6, epsa A is equal to epsa X, which is horizontal or say along the line OX, and epsa C is equal to epsa Y, which is vertical along the line OX, and epsa X dash is the epsa X dash cos theta epsa X, and epsa X dash is given by epsa X cos square theta plus epsa Y sin square theta and gamma XY sin theta cos theta, where epsa X, we have considered that phenomenon of this strain analysis is that which was told us, say a straight line over a surface of a body which are of length say P and P to Q, and after deformation that straight line takes the position of P dash and Q dash, and we assume for our convenience sake the initial point P dash of this vector is not shifted, it remains P, and the final point is shifted to P dash, so there is an internal angle between them is equal to theta. So By the action of the external force, the straight line PQ has rotated to a certain extent equal to angle theta 2 and assumed a new position P dash Q dash. And the eccentricity of P dash Q dash, which is not equal to, I mean, the length of P dash Q dash is not equal to the length of PQ, and it is the eccentricity is given by EX dash by the formula f psi x cos square theta plus f psi y sin square theta plus gamma xy sin theta cos theta, where theta is the embedded angle, x psi x is the strain along x-axis, f psi y is the strain along y-axis itself, and f gamma xy is the shear strain in xy plane itself. We have discussed and proved this theory earlier part of our discussion. Now, here what we are assuming that f psi a is equal to f psi a, and here it is working along x-axis itself. F psi y is equal to f psi c, which is acting along y-axis itself. And gamma x square xy cannot be measured from any of these three rosets. We have to calculate that, or we have to measure it from this in the motorcycle itself. So theta here is the incident angle between the f psi b and f psi a, or the incident angle between PQ and PQ dash, which the incident angle between the two positions of the straight line PQ before and after the deformation itself. Now, f psi x is the increase in length of the of the line PQ from P dash Q dash from PQ dash, where PQ dash is not equal to PQ. So what happens? F psi x, f psi a, f psi y, and f psi c. We have to know these values, and we put f psi x is equal to 320/3 with f psi x along x-axis. F psi y is known to us. We put around 700 f psi x is equal to f psi a is equal to 7, f psi a is equal to f psi x 700 to the power minus 6. We put this equation here, and f psi is f psi a. F psi y, we put it 300 to the power minus 6 into plus half and plus half into gamma xy plus half into gamma xy itself, because you see here cos square theta is for cos 45 degrees equal to 1, and cos 45 degrees is equal to 1 by square root of 2, and sin square theta is equal to, just 1 second please. Hello. Hello. তিনটা চারে আছে আমার, ওটা কালকে দেওয়া আছে আমার নাম। না, একটার হচ্ছে আমাদের গ্রুপের, সেটা হচ্ছে 6 নম্বর গ্রুপ, সেটা আমার সবাই আছে, ঠিক আছে? হ্যাঁ, সেশন 6। আর আমাদের ইন্ডিভিজুয়াল টেকনিকের জন্য বিভিন্ন গ্রুপে বিভিন্ন নাম আছে, আমার আছে 3 আর 4 নম্বর গ্রুপে। সবই আছে। আচ্ছা, আমি একটু ক্লাস নিচ্ছি, একটু পরে বলছি আপনাকে। হ্যালো। Things are like this. Cos square theta is half, and sin square is equal to half. Sin square also is equal to half itself. So this plus this multiplied, total multiplied by half, is equal to sin theta into cos theta. That's also half gamma xy. And here f psi x, we are taking it as the length which is changed after the external application load or after deformation, is calculated as f sub b itself, which we put here as 300 to the power minus 6. So our node was f sub x dash along OB, and OB, f psi x along OA, f psi y along OC, and gamma x1 is unknown to us. So, and theta is known equal to 45 degree. You should put the value of cos square theta, sin theta, cos theta, and ui, fx, and fx dash, all one after another, and thus gamma x gamma xy is equal to minus 400 into 10 to the power minus 6 itself. Now, for principal stresses, principles to calculate the principal stress, we know epsilon 1 and 2, maximum or minimum principal stress is epsilon x plus epsilon y divided by 2 plus minus square root of xx minus epsilon y is epsilon x plus epsilon y by 2 plus minus half square root of epsilon x minus epsilon square plus gamma xy whole square. So this becomes equal to 700 plus 300 divided by 2 plus half 700 minus 300 whole square plus 400, and if the whole multiplied by 10 to the power minus 6, which is a common item for all of them. Thus it becomes 500 into 500 plus minus 200 into square root of 2 . Now, epsilon 1 plus epsilon 2, epsilon and epsilon 2 is epsilon x plus epsilon y by 2 plus minus half epsilon x minus epsilon whole square plus tau into gamma xy square. We have calculated gamma xy. We have epsilon x and epsilon y is given to us. If we put out this value, then it will happen. If we put out this value, it will happen 500 plus minus 200 square root of 2 into 10 to the power minus 6, and epsilon max will become epsilon 1, which is the maximum. Means we have to add this thing with this, we'll get epsilon 1 782.8 10 to the power minus 6, and epsilon 2 217.2 10 to the power minus 6. Now, the direction of the principal strengths are always to be found if phi is the maximum principal stress with EA, means along x-axis or along the A strain gauge. So tan y 2 phi is 2 gamma xy epsilon x and epsilon y. We put this value one after another, 400 minus 400 y is equal to minus 1. So 2 phi will be either minus 55 degree and or 135 degree itself, and phi will be just half of them, 22 half or 67.67 into half. Now, the graphical representation is shown in X figure. We should line away, just showing you. The graphical representation is like this. First, what we have to draw one x-axis and we have to draw one y-axis as per our convenience. And OY dash is the y-axis and parallel to BC, and then parallel to BC and AD. Y-axis, there will be, let us draw the sigma B and sigma A, I mean epsilon B and epsilon A as the straight line at a distance from E and from D itself, and where both B and C are of the same value, so this line will coincide on the same line, which is intersected with x-axis as E, and A has a higher value intersected with y-axis as D itself. This is all article over x-axis itself. Now, the reading of strain gauge C. Now a point on B, just like here, any arbitrary point on B is given as PE, and draw a line at 45 degree to BC itself. So we have first got this point here, we choose any arbitrary point here, and then draw a straight line with angle 45 degree from here to A. and drawn another straight line which is at an angle 45 degree with the PC as well as it is a tangent of B and C. So this angle BA is equal to intersecting at O and gives us the center of the whole circle itself. And with the distance from O to B, we can draw a more circle, and where which is the line BC to A. BC itself is intersecting it, and line A is also intersecting it, and the angle between OA and OD is between phi. Is that the maximum is given as the angle maximum angle of the principal stress axis, and principal stress is given as O dash F as the major stress, and O dash 2 O dash Z is at the as the minor stress itself. Other calculation is it as per the our task calculation here. Now here we have a trident delta X rotor. The strain reading are 1000, 720 and 600 microcentimeter per centimeter respectively. Find the principal strain, we get the solution. The let ABC is the strain gauges so that EPSA A, EPSA B and EPSA C are 100, 750 and 720 degree microcentimeter respectively. What we see here, I am going to the next page, but let us clear one point here. Here there is a strain rosette. Here EPSA A is going on, and what is given here is here what is given EPSA A. This is plotted along x-axis, and EPSA B is given plotted along EPSA B, and EPSA C is plotted along this line. Here in this drawing, it is given that EPSA B or EPSA C is not coinciding with EPSA A, EPSA Y. So that none of them, and so they have internal angle 120 degree towards each other. They are subtending the same angle with each other. So it's forming a part of a triangle itself, but it is not. You cannot use EPSA B as OY as EY, and you cannot give EPSA C as EY or itself. Only you can give EPSA A at EPSA F itself. So along these two decisions, we have to take. We will have two parameters. One is EPSA Y, another is gamma XY, where we are given strains are along A axis, by B axis, and C axis itself. Just share, stop share. Now, starting from the first principle itself, we know that f psi x is given as 1000 into 10 to the power minus 6. F psi x dash dx into cos square theta plus f psi y sin square theta is gamma xy sin theta cos theta, where f psi x dash is the elongation of the particular straight line which was initially at PQ. Now, due to the external load, it is deformed and take the position PQ dash itself. And in between angle between x and y, in between angle between uh, x and y is equal to between this PQ dash and PQ is equal to theta itself. And what we have seen, the eccentricity along x-axis cos square theta plus eccentricity y into y-axis or y sin square theta plus f gamma xy shear strain in xy plane is equal to sin theta cos theta, which will give the eccentricity of the line PQ dash itself. Now, what is problem here? Here, one of the axes that is on f psi x is coinciding with the x-axis itself. But as per the given figure, none of the axes x y and x x dash is coinciding with y-axis itself. So, y-axis strain along y-axis is not available in this line. We have other strain in other lines. We have to use them, and how we can use? We have to calculate like this. Say theta when the f sub b is acting 120 from 0 angle is given as here f sub x. We put that f sub x is equal to 720. But this is a deformation, and f psi x 1000 into 10 to the cos square cos 120, which is 1/4, which is actually half and 1/4. F psi y is equal to f psi multiplied by cos square root by 2, that is 60, or 120, that is 3/4. Square root 3/4 to is equal to 3/4 plus gamma xy into 1 minus 100 square root of 3 2. Because 100 theta 120 is equal to not equal to half but minus half, and theta cos 30 is equal to again 60 degree and is equal to cos 30 degree is equal to square root of 3/2. Again, for theta 220 degree, the eccentricity along the line OB is equal to 600, and line AX is 1000, line EY which is not known to us, and line gamma XY is given as square root of 3/2 into half itself. Now, f psi y and gamma xy, f psi y and gamma xy is not fully, f psi y and gamma xy are not known. Here f psi y and gamma xy is not known. So we have these two equations. We will calculate what is the equation for f psi y and gamma xy. Thus f psi y becomes this is the value, and gamma xy is equal to minus 138.73 value. And what will be the solve the equation for you get f psi y is this and this. F psi 1 to 1000 into 546.7/2 and equal to half square root of 500 into the power So we can put 1000 as 1000 plus P1 and P2, maximum minimum, or Px minus Py. So we get Pi here. Px already we have had. So Px minus Pi/2 plus half Px minus Pi whole square plus minus 130.7 whole square. (773). There are two values of x1 and x2. One is semi-maximum, the 773 plus minus 236.5, and this is equal to 1000.9 V 10 to the power minus 6 or 356.8 to the power minus 6. Let us go through the new item, polar strain in polar coordinates. So far we have discussed all the displacement, velocity, etc. are measured and plotted in XY Z coordinates or Cartesian coordinates. But there are other coordinate systems. One is maybe useful to us, that is polar coordinate system, where instead of three parameters like x, y, z, we have two parameters. One is r and one is theta, which means the displacement and difference in the two-dimensional radial elements, we have to discuss them in polar coordinates itself. So far, we have discussed them done with the Cartesian coordinate itself, and now we are supposed to do the polar coordinate itself. The polar coordinates of a system at say at point A, which is equal to r and theta. If we drop a, we already plotted here x and y here. Okay. According to the theory, that theory of the we plotted theta angle equal to theta itself. Here we are considering all the displacement and deformation of the two-dimensional radial element in polar coordinates itself. The polar coordinates of a point A are r and theta. So here we have this point. We call this point A here as r and theta and upwards accordingly. The radial circumferences are denoted by the radial circumference displacement are denoted by ur and u theta itself. If there is any change in the displacement of the particular point, then they are denoted by ur, and if along the radius, it will be along the radius will be ur, and along the circumference it will be equal to pi. Now, polar coordinates r theta is displaced point with the coordinates r theta gets displaced by deformation to position A. Now, radial circumferences are denoted by ur and u theta. Consider elementary radial element ABCD as shown in the figure itself. So this is x and y, and this is polar coordinates. We have the coordinate system along the radius and coordinate system along the theta. Means we have to measure and plot everything by means of the radius itself as well as the angle subtended by radius with the x-axis itself. This is the method of this type of displacement itself. Now, we got point A with the coordinates r theta. Now, due to the application of some external force, got deformed to a position, say here. Point A is with coordinates r theta, gets displaced under a deformation to position A dash with coordinates u plus r dash. So, in the picture, what we have here, this is the point A. Now, it displaced, and this is the point A, this is the point A dash. And after the external application of load, point A will be displaced to point A dash itself. And this is what we have told. polar coordinates r and theta gets displaced with the after deformation to point A dash with coordinates they change to u plus u1, and alpha coordinates is radial coordinate is changed to r plus u1, and I mean your circular coordinates or polar coordinates change to alpha plus the theta plus alpha. The u1 is the change, alpha is the change. Now, next, what is the neighboring point? Here, neighboring point is P. Here, theta remains same. This is the theta for the neighboring point A. This is A dash, this is A, and this is A dash. The neighboring point A has supposed to be have the same displacement. That is why it remains there the same. Now, so point A, you have r theta, point A dash changed to r plus delta r, and theta is also changed to a certain extent. After deformation becomes to point A dash with coordinates change, radius change to r plus u1, and theta also change. Radial distance is equal to r plus delta a. Neighboring points B initially got moved to B dash. It was initially was x plus x plus x r into theta r plus delta r, and point theta gets moved to B dash with coordinates r plus delta r into er plus r plus u r into er into r x delta r plus alpha, comma r plus alpha delta r by delta r into delta r itself. Okay, time is going short. I'm stopping the share here. Participants. The class here.